The second example circuit included with the starter kit adds a potentiometer to your blinking LED in order to have some external control over how quickly the LED blinks. A potentiometer is essentially a variable resistor, and we'll be moving over to the schematic where you can take a look at how it's pictured there, and I'll explain a bit more about how a potentiometer works. So for our schematic, we've got our Arduino unit, we've got an LED, we've got a resistor, and we've got our potentiometer. The potentiometer is pictured here as VR1. It's got 3 ports, as it's essentially a resistor that has a stylus or a brush touching somewhere partially on the resistor. And it functions essentially as 2 resistors connected in series. And the voltage read off of the brush in the middle is dependent on how far to one side of the resistor or the other it is. If the brush is all the way on the side that's connected to the 5-volt power supply, then it's going to read 5 volts there. If it's all the way on the other side, it's going to read 0 or near 0, because the potentiometer's total resistance in this case is very, very large compared to the voltage provided by the Arduino, in this case 10 kiloohms. So when the brush is all the way at the far side of the resistor, it's going to read as 0 or near 0. So to hook our potentiometer in, we pull off the 5 volts from the Arduino pin and connect it to one side of the potentiometer, and then we're going to connect the other side out to ground all the way out on the far side of the diagram in order to try to keep things neat. The actual reading pin, the brush pin potentiometer, we're going to connect back to the A0 pin of the Arduino. This A0 pin we're going to be using as an analog read pin. It's going to look at that voltage, and it's going to convert that voltage into a number from 0 to 1023 along the same sliding scale from 0 to 5 volts. So it will read 0 volts and provide 0. It will read 5 volts and provide 1023. And it will provide a smooth sliding scale for everything in between there. This is because analog signals, like your electric circuit and that varying current through it, will vary smoothly between 0 and 5, whereas your digital signals are simply on or off. They'll be 0 volts or 5 volts. Now, in order to show that, yes, the potentiometer's having some sort of varied difference, and we can actually see what that varied difference is, we're going to connect an LED to digital pin 13, connect that LED to a current limiting resistor, and connect that resistor to ground. And we're also going to connect one of the ground pins of the Arduino to ground. So note this crossing right here. Those wires cross but do not join. So the current flows from left to right in the horizontal wire and does not mix with the current flowing from top to bottom in the vertical wire. These wires, it's as if you took 2 insulated wires and laid them on top of each other. They're not connected, they're not sharing current. The difference is over here. This is a junction. Those wires are all connected together. If there were a dot inside this cross over here, that would be a junction, and those would all be considered connected, and we'd also be shorting 5 volts to ground, which is not something you should do for any power source. So we've got our potentiometer connected to 5 volts, connected to a read on the Arduino, and then we've got a digital output from the Arduino to the LED, which is going to take what we read off the potentiometer and do something about it. So our actual Arduino sketch here, the comments for this sketch go into what's a potentiometer and how the potentiometer works, and talks a bit more about LEDs. So first, before they even do setup, they're defining some global variables. So int sensor pin is 0. So they're defining their sensor pin as 0, so they can use sensor pin instead of 0 for any of these sort of analog read or write or digital read or write commands later. They're also defining int LED pin as 13. Once again, that's so they can just use LED pin later in the program in all the places where they need to use pin 13. Now the upside of doing it like this, defining these as global variables way at the start in a sort of set of declarations rather than just including 13 every time you say the LED pin, is if you, for example, want to change your LED pin from 13 to 10 or 9 or 12, in this case you go up to your declarations and you change 13 to 12, and since it's referred to as LED pin everywhere else in the program, it just automatically aligns to all of those as well, so you don't have to find every instance of 13 in your program, figure out whether it's referring to this pin, and then change it to the new pin that you want it to. So we move into setup, the things we want it to do once before the sketch actually runs completely, and we're formatting the LED digital pin to output. Now, the comments below state that, yeah, we're not configuring the analog pin as an input. They're always used as inputs, so we don't need to configure them as an input when they're being used as one. They are treated as inputs all the time, unlike the digital pins, which could be an input or an output. Now we move into our actual sketch, the void loop. So first they define a variable, int sensor value, which they're going to use later for whatever it is they pull off of their potentiometer, which they proceed to do down for this next one. They assign to this variable sensor value that they just created analog read of sensor pin. So sensor pin was defined as a global variable 0, and analog read says go to the analog pin mentioned as that parameter, so pin 0 in this case, read its analog value, convert that to a number, which will be 0 to 1023, and then store that in sensor value. Now, the remaining bits should look familiar. This is just your LED blink again, except this time, instead of delaying for a fixed 1 second, they are delaying for sensor value. So it will remain on for sensor value and turn off for sensor value. Note that the digital write commands include LED pin as its parameter, which in this case is 13. If you wanted to use pin 12, instead of finding every instance of 13, you go back up to the global variables, change your LED pin to where you want your LED pin to be. So, when it says delay for sensor value, that means it's reading off that potentiometer, and it's going to wait a number of milliseconds according to how many volts it's reading off the middle prong of that potentiometer. So when the potentiometer is almost all the way at the power source side, that's going to read 5 volts. That's going to be converted to 1023. So the blink will be its absolute longest when the potentiometer is almost all the way on the side of the power source. As the brush moves towards the other side of the potentiometer, towards ground, that's going to approach 0, and the LED will blink faster and faster to eventually, since this delay can become so small, just fractions of milliseconds, so close to 0, that the LED can actually start blinking faster than your ability to track that it's blinking, and it will just appear to be solidly on or solidly off. In fact, its brightness might appear to change depending on how quickly it's blinking. So, if we take this sketch and upload it, depending on where my potentiometer is located, and I've got it turned all the way to one side, or I've got it turned all the way to one end, so it's either currently at 5 volts or 0 volts. I'm either going to have a solidly lit LED or a blinking LED that's going to blink for about 1 second on, 1 second off. So let's upload that sketch and switch over. And as you can see, I've got a blinking LED that's probably in the realm of about 1 second on, 1 second off. Now this blue little twisty knob right here, that's my potentiometer. So if I go over to my potentiometer and start turning it, moving the brush towards the other end, you should see that the LED starts blinking faster and faster. Stays on for less time, stays off for less time. So as it blinks faster and faster and faster, and eventually I'm going to get to the point where I can barely even tell it's blinking anymore, and there, it's switched into it's blinking so fast that it looks like it's on, but it's not fully bright. Because it's actually spending half its time on and half its time off. So it looks about half as bright as it should be, but it's just fully, it's blinking that fast. So if we twist back this way, you'll see that it's going back to blinking, and yes, it's much brighter than it was when I've got it all the way down at 0 volts. If we twist the potentiometer all the way back up to 5 volts, that's maximum delay, and it's blinking on for 1 second, off for 1 second. So this sketch here takes an input value from your potentiometer and shows you how to use it as an output value on that blinking LED.